Welcome. This video will discuss how to categorize a quantitative variable. This is a skill often used in practice when there are commonly defined groups based upon a measured variable. For example, we might want to provide information about body mass index categorized into underweight, normal, overweight, or obese, or classify individuals having high or low values for a particular variable, such as high systolic or diastolic blood pressure. In addition, there are often other reasons to categorize variables, varying from the intended audience to the need to handle nonlinear predictors in multiple regression analysis. Here we will categorize the body mass index variable created in topic 2D into a binary version, which looks at overweight, BMI greater than or equal to 25, versus not overweight, BMI less than 25. And a multi-level version which categorizes into the standard categories. We don't have any missing data here, but in practice, if you do, you will need to make sure that they are handled correctly. In SAS, missing data are ordered as negative infinity, so that if you try to select all values less than a number, the missing values will be included. If you always specify 2 endpoints for each category, then you can completely avoid this issue, and we will do that here. In order to follow along, you will need the SAS dataset pulse_step 3 after creating 2 new variables. Before we start creating the variables, let's run procmeans on our step 3 data to determine the minimum and maximum for the variable we will be categorizing, BMI. We can see that for BMI, the minimum is around 16.5 and the maximum 32.1. We will go slightly outside this range in creating our groups as needed. Also notice there are 107 observations. We use a data step to create new variables of any kind. For this type of categorization, we use if-then statements. There are other options such as if-else statements, but we will only learn this one way to categorize quantitative variables. In practice, it is best to avoid having more data steps than needed. Usually, you can continue to modify your original data step later if you need to make changes. If you do work in stages, you must be careful to make sure you start from and save to correct data sets, as common errors include starting from the wrong data set or overwriting your original data with data that contains some kind of problem, which would require re-importing the original data and starting over. We work in stages in these tutorials due to the fact that they only cover one topic. Our SAS code has the formats already in use for this data set. Before we submit this code, since we will need 2 new formats, we will go ahead and add them here. We will be creating 2 categorized versions, one with 2 levels and one with 4. So I'm naming the formats BMI_2 and BMI_4. SAS does not allow us to end a format name with a number, so I use the word instead. The 2-level variable has 2 groups, less than 25 and greater than or equal to 25. In practice, we usually use words to describe groups, but since the project asks you to use numeric ranges, we will do that here. Since SAS doesn't easily allow us to put the greater than or equal symbol, I will use 25 plus to indicate that the 25 is in the upper group. For the 4-level variable, we can use an algebra-style notation to indicate whether endpoints are included or not. You can put anything that explains exactly what happens on the endpoints as long as it's short enough to be reasonable for translations. Here we use less than 18.5 for the first level, algebra notation of bracket 18.5, comma 25 parentheses, and bracket 25, comma 30 parentheses for the middle levels, and 30 plus for the last level. Now we submit this code and check the log file to make sure all of our new code worked. Be sure to check each format in the log file, as it will run what it can but skip formats with errors. If you don't look back to the top, you might miss an earlier error. Now we start our data step. The first line gives the new dataset name, so we will make this step 4 with data bio.pulse_step 4. Then in our set statement, we add the data set we want to use as our starting data, We will use the step 3 dataset with set bio.pulse_step3. We start by creating a binary variable which looks at overweight or worse versus less than overweight. We need to decide on a name for this variable before we can begin. We will use binary BMI. The cutoff for overweight is a body mass index of 25. Technically, 25 is considered overweight, so we want it counted in the higher category. We add the following statement. If 15 less than equal BMI less than 25, then binary BMI equals 1. The statement tells SAS to create a new variable binary BMI with a value of 1 if the original BMI variable falls between 15 and 25, including only the lower endpoint. Notice that this says mathematically that BMI must be greater than or equal to 15, but less than 25. Now we add the second statement, if 25 less than equal BMI less than equal 33, then binary BMI equals 2. This defines the new variable binary BMI to be 2 when BMI is 25 or larger. We chose the 33 and 15 based upon the min and max calculated earlier. We chose a reasonable integer outside of the range of the data. Any values outside of the range of the data would work. Now we add the code for a multi-level version of BMI, which I decided to name BMI groups. Here we have 4 if-then statements, one for each level of our categorized version. The cutoffs used are given in the dataset information document. Now let's label and format these new variables. I will label binary BMI as binary body mass index and BMI groups as body mass index categories in a label statement. Then we connect the two new variables to the formats we created earlier using a format statement. Now we can run this data step and look at the log file. The dataset used had 13 variables. We added 2 new variables, and the log file says our resulting dataset, step 4, has 15 variables. Running procprint, we can see we have 2 new variables, binary BMI and BMI groups. Since we already formatted the variables, we see these formats in our procprint results, but in fact there are coded values in the background that now we do not see. If you want to see that step, you can run the data step before adding the format statement and see the difference. We can also run procfreak now to check our work. Our total for each variable is 107, which is correct. Also, due to the way we created these variables, we know that the first 2 levels of the BMI groups should end up in the first level of binary BMI, and our total of 15 plus 73 does indeed equal 88. The upper 2 levels in BMI groups should end up in the second level of binary BMI, and again our total of 17 plus 2 equals 19. We have successfully created a binary and a multi-level version for BMI in our data. They are correctly labeled and translated and ready for further analysis. That's all for this tutorial.